Needed. So my name is Björn Ratjen, as you can see out there, I intend to give you a little bit of information, but I'm really open to a discussion, and the discussion that I want to have is pretty much on why we're doing it, what is our contribution, and I'm also open to some technical issues around engines, because I'm one of the guys that likes to dig into the core of engines and have some experience with that. So I'm willing to answer any questions around that. And I also will combine this venture here with a field trip to my car, which is outside, so you can see actually the systems, the straight vegetable oil systems, a modern system installed in the car, how it looks, and I can give you an explanation how it all works. All right, I don't have the only thing I forgot is a watch, so actually kind of bore yours. Taking people's watches, that's a good start.
Yeah. Is it rolling?
Turn around. All right. So, biofuel systems. I'm just giving you the whole thing here. The big question is, why are we doing what we're doing? You know, biodiesel, straight vegetable, ethanol, why are we doing it? The big key thing is because it's renewable energy, and it's also in a form that is easily adaptable to the transportation vehicles that we're using. It makes environmentally sense that we take something that is renewable within a growing season as opposed to a couple million years. However, all that has also a limited supply. I mean, plants are limited, the Earth's surface is limited, as well as what's in the Earth is limited. So, liquid fuels are easily adapted to existing forms of transportation. And, you know, all the machines that run a combustion engine, internal combustion engine, depend on liquid fuel. And if you go to a supermarket or a grocery store and buy any food, every piece of food that you touch has been touched by a combustion engine, and mostly by a diesel engine too. Even if you saw Josh's film on Friday, when they produce ethanol, you see these big diesel engines doing like the cutting of the corn, the transportation, the grinding up and all that, that's all diesel engines. So there are different types of engines, but if we use renewable energy, we are a bit less hard on the environment. If you use something that's renewable, it's also sustainable. Sustainable over the long run. If you have something like the mineral oil, and you know about peak oil and have all the information about that, I hope, we can remake some of it. One problem, of course, that came out also in the last presentation that was here, we're only part of the solution. We cannot be the total solution. The total volume of consumption of liquid fuels is so high that other changes need to be made in order to be completely sustainable. And we just have to be aware of that. It's a part of the solution. It's not an end-all and complete solution. CO2 neutral, that means if we grow a plant, the plant releases oxygen, which we turn then over and release CO2 and other substances, nitrogen oxides, and so forth, that are released with any combustion process, with any fire. If you have a campfire, you have those coming out. But CO2 neutral means that we produce the oxygen that we also breathe in, and also release, hopefully in equal quantities, of the CO2, which we cannot breathe in, which is a problem. You know, you heard about the carbon footprint. So we're reducing that to some extent, but also not completely, because we're still producing CO2. I just want to create that awareness in all of us, that we're not the end all, if you look at the global problems that we're facing. The other thing, what it does, it generates independence. That we can brew our own fuel. In the case of biodiesel, we can go to, like I do, to a restaurant, pick up some containers and put them into my car from waste vegetable oil. So it creates some independence. And at the same time, it also creates some work, because we have to work for our fuel, because there are not the ubiquitous fuel stations available all over the place. So there are always some pros and cons. The problem with us as mankind, as people, is that we need to really be hit with some of the consequences of our action because we maybe do some changes. I mean, on another topic, just look at the economic situation or the financial crisis, and it's still an effort to do business as usual. At some point you go, duh, you know, do we not need to change something here? And so that's why I'm in it. That's why I'm in it, because I want to make a change. And yet at the same time, I'm also sometimes very frustrated because what I'm contributing is like minute. So I feel sometimes really deflated about it all because, you know, I can only make so much of a contribution. Which in turn means that please let's all work together whatever fuels we're using. And one note on the film that was shown on, that Josh showed on Friday. Okay, there are some issues with ethanol, and I'll talk to those in a bit, but it's also can be a part, and only a part of a solution. And I underline the word part, not more than that. Okay, and you have to ask yourself, why are you doing what you're doing? And what is your contribution? What is your moving force? Because you do something extra, which is great. But what motivates you? And how to keep that motivation going? General consideration of transportation. As I said, you know, what we're doing is not only a partial solution. And there are certain considerations that we have to look at. We cannot just continue to drive the same way, the same routes, use the same high volume engines, the same heavy vehicles, and use biofuel and feel smug about it all. It's not working. Because if you drive a big truck or an SUV, you're transporting a piece of metal. Your weight is just a small amount in the whole equation. So you have to consider transportation needs. Internal combustion engines are not good for short-term hauls. It increases incredibly the wear on the engines, and they're just not made for that. So then we have to think of alternatives like electric vehicles, where we have to be also considered, where does the electricity coming from? What is the source of it all? In cities, and more than 50% of the people now in the world live in cities, you have to balance between individual and mass transportation. Mass transportation is the way to go when you have people living together. It's more difficult in rural communities. And you have to consider your own lifestyle. We all have to make lifestyle changes. I mean, I'm saying the things that are maybe the uncomfortable truth, like using a famous quote here. But we have to make changes if we want to affect what we're doing here, and if you want to have a larger effect. And there's a thing, you know, if you go into business and production, then often bigger is better, or more is more money. The more biofuel produced, for example, translates then into money because you have bigger plants, you amortize that and stuff like that. That's the system we work under. And so that can lead also to then supporting habits that are in the end not sustainable. Habits of vehicle transportation that's not sustainable. So I ask everyone here to think more in a global context with every step that we're doing. And I can only ask that. The real step is up to you. The other consideration is climate in different ways. What effect do we have on the climate? And what climate do we live in order to make the transportation available and sensible? And I mean, combustion engines are great because they work in almost any climate with some modifications. Diesel engines especially depend on heat, and they're heat engines. They run on basically on internal heat that they produce themselves. So they rely on heat, especially for startup. So there are some issues in northern climates, in cold climates in the winter. But they can be resolved. It's all resolved. It's all mechanical stuff. You can, if you wrap a blanket around you, then it keeps it warm. And if you apply some heat, then you keep it warm, the blanket. So there's some mechanical issues that can all be resolved. The problem that we have is that we have big corporations like the oil industry and the automotive industry that are in bed with each other that dictate basically where we're going. And the governments fit in, look at how the automotive industry is bailed out, and the same strategies still are happening. So that's where I become really frustrated, because then I think, well, what changes are we making? And yet I slug on, and hopefully so do many of you. Another consideration is the access to fuel. It's very easy to go to the gas station, pick up the nozzle, pay, put the credit card in, and fill up. If you go alternative fuel, there is no system set up yet. And it will take some time till it is. So it's more cumbersome. It's more inconvenient in that way. But that's part of where you have to check what's your motivation to do all these things. And that's part of where we all need to go if you want to make a difference. And much talk has been done about the footprint, the CO2 footprint, the carbon footprint. I ask each one of us to just take that into consideration. It's not that every one of us has to run around with a bad conscience all day, because that's very depressing. But just please be part of a larger consideration. I'm very involved in what I'm doing, and people get very involved in what they're doing. I think it's the greatest in the world. But, and that's nice, that's the motivation, and wanting to do a good job, wanting to do something. But in order to tackle the larger issues, we have to consider the larger piece of this planet, some way or the other. So the Environment Impact is a local one, is an individual one, a local one, and a general one. So, biofuel systems. Let me talk just for a moment about ethanol. Ethanol is it's alcohol that's for gasoline engines. Gasoline engines have a lower compression, like, I don't know if most of you, I'll just give a quick explanation. So when the air is compressed, there's a bit of a gap between the cylinder head and the piston. And so it heats up slightly, the air, or actually quite a bit sometimes, heats up, and at the top, and then the mixture between fuel and oxygen is ignited in gasoline engines by a spark plug. And you heard about different compression ratios, maybe in engines. Some engines require the higher octane fuel. What many people do not know is that when the higher compression engine is active, that it creates more heat. So the danger is that the mixture that is put into the combustion chamber ignites actually earlier than wanted. So the higher octane fuel puts some limiters on that and actually increases or decreases the likelihood of combustion slightly in order to have a more accurate combustion, because when the explosion happens, you want to happen at an exact point so that the piston is pushed down and that translates into the energy. Ethanol is more volatile. So there's some issues actually with ethanol, and you have to reduce actually somewhat the capacity of ethanol because you want to have an accurate combustion point. So additives are often needed in order to stabilize that combustion for engines. And ethanol also has the issue that it attracts moisture. So that's why people say you cannot have 100% ethanol. It's always like between 95 and 99% or something like that, because it likes to attract water, and water is in the engine can be really corrosive in the intake, so it can have some problems. The other issue with ethanol is that it takes, and that was documented in various things here, that it takes a lot of energy to produce ethanol. It's another issue to be concerned with. Why are we talking about ethanol? The reason is, in North America particularly, that simply put, the North American car manufacturers have not been able or willing to produce a decent small diesel engine. So they poo-pooed all the efforts of the small diesel engine. they have large-scale diesel engines. Some are good, some are better, some are not. And often they're overfed, these engines overfed with fuel, which leads to the big smoke coming out, which has given diesel the bad name that the diesel is smoking, which it doesn't need to do. Jerome, shut up your phone. Where was I? The diesel engines. So that's why we have a glut of gasoline engines here, even though gasoline engines are about 30% less efficient than diesel engines. If you would change, like say, half of the gasoline engines in North America, the small gasoline engines, to diesel engines, billions of liters of fuel would be saved every year. And that's what's happening in Europe. In Europe, every second passenger car is a diesel car, so it's about half and half right now. But again, ethanol, I understand what Josh was saying, that you say he has to sort of convince the masses to go into that direction. Yes, on the one hand, yes, I would say I can see that point and concede that point, and yet, if then people drive around with large, huge vehicles, going shopping, you know, around the block, and use a huge amount of gasoline and fuel for that, or ethanol, and feel good about it, that doesn't make me feel completely satisfied, because we're still increasing the overall consumption of fuels. So there has to be something else attached to that. Some other change of lifestyle. Diesel engines have the same basic principles, that they compress air which heats up, but they compress the air or the gas way more, and so the gas heats up actually so much that it explodes when fuel is injected. At that point, so they don't need a spark plug, they just work on heat. Which creates a problem when the engine is cold. That's why you have glow plugs to have a little bit of heat in there to start the ignition process. Diesel engines have the advantage that they're more efficient. They produce more torque, more advancing power at lower RPMs. They generally run at lower RPMs and therefore don't use as much air and fuel. And the torque curve, like when you look at the explosion in detail, the gasoline engine is almost like if you use a metal hammer and hammer on that table. It's like a very instant, quick explosion. Diesel engine is like if you use a rubber mallet and hit on the same table. It's more softer, the explosion, and that's part of why the diesel engines also last longer, because they, in that sense, easier on the general running of the engine, but they also need to be built sturdy because the explosion itself is a bit stronger, but it's like a more gentle curve. In diesel engines, in addition to the regular diesel, we can use biodiesel, SVO and WVO. SVO is straight vegetable oil, WVO is waste vegetable oil. The problem, as we all know, hopefully with vegetable oil, is that it's thicker, it has a higher viscosity than the diesel fuel. And all the engines that we deal with, because we're not manufacturers, are optimized towards the diesel fuel. So you have to reduce the viscosity. One way is to do it chemically, using a catalyst, transesterification. You've heard a lot about this weekend, and probably most of you know about that. And then you get a fluid, you get about 20% like thick gooey stuff, glycerides, and then you get 80%, about 80%, which is called biodiesel, which you can ideally, after some further processing to get the catalyst out, can pour it into your tank of a diesel engine and run. SVO, WO is, and that's what I do, is instead of converting the fuel, I convert the vehicle. I install something in the vehicle that makes the fuel thinner. What's that? Well, anyone who has been frying something in a frying pan knows when you put fat in the frying pan, it melts and thins. So what I'm doing is I'm using the excess heat of the engine and some electrical heat to propel the car and to get to the same viscosity of the diesel fuel. So the difference is, in the scenario of SVO and WO, you have to take a one-time investment to add some stuff to the car. And usually what I add is a second fuel system that you can switch over between the two. And biodiesel you can use without, in most cars, without modifications. Now, I won't go very much into this. The food versus fuel debate, there was quite a good segment on that on in the film on Friday. One interesting point, though, that I want to mention is that the whole ethanol thing was also initiated largely by farmers that wanted to have more profit for their crop. So it's another part of the whole equation. And of course, if you say, okay, we use arable land, well, we use crops that are not good for consumption anyway, then the question is, but you could use it for crops that are good for human consumption and so forth. So the food versus fuel argument hasn't materialized, and it was a propaganda item. It was definitely a propaganda item. I was furious about that, and I was furious also how well many people fell prey to that. That, you know, like, well, Josh had that in his movie, that, you know, people said that's like genocide or whatever they said, you know, crime against humanity and stuff like that. It was just propaganda, and very effective propaganda. I mean, food versus fuel, it's a catchy line, isn't it? And of course, it must never come to that, and the food prices are really dependent on the transportation prices, which is equal the mineral fuel prices. That was the key. That was the stuff that drove the fuel prices up, and it's been proven over and over again. But when we think about using plant oils, we also have to think about that. We have to think about that a little bit. What are we doing? And that's a bit my plea to use something that has already gone through the food chain, has already, you know, gone through some processing, and using a waste product. And that's the waste vegetable oil, which you can make into biodiesel or you can use straight, you know. So these are the two options. Of course, you know this famous quote of Diesel, Rudolf Diesel, good old Rudolf. He was a visionary at his time, and he presented his first engine on peanut oil. I've never personally tried peanut oil. That would be nice. And I thought about, just was joking to someone the other day and said, we should get everyone, you know, when they buy a jar of peanut butter to take the top oil off and save it, you know, and, and then you can fuel. It would be worth trying, huh?
We'll sell you an additive.
Oh, for the peanut butter itself, don't put that in the tank, yeah? Well, you have to make some lifestyle changes, come on. So, diesel engines, diesel engines were made for plant oil use, you know, I just said that. They're more efficient than gasoline engines, and they are also extensively used in farming and transportation. Look at all the trucks, and look at like all the equipment that runs on diesel engines. The only problem is the strategy that the manufacturers in North America have chosen by not producing a good small diesel engine. So by using a diesel engine, you're already one step ahead, in a sense, you know. But diesel engines have other issues. They do have some issues with other emissions with particles. And what they're doing in Europe is they put particle filters in, or the urea, they feed in some steer piss, basically, to put it bluntly, or derivatives of that, to further have to catalyze the emissions a little bit. What's happening though is that all these things, they're technical issues, and they can be overcome for plant oil use, for biofuels. And the problem is that the car manufacturers create standards that are dependent or in line with the standards that the oil manufacturers use, and then they say, well, this is when we only give our warranty, otherwise you're out on your own. And so that's the big lever that they have. The technical issues are easy to overcome with almost all diesel engines. There are some issues with diesel engines, there are some issues in using biodiesel in some engines, and there are some issues with plant oil generally too in some diesel engines, but they can be overcome. So, as I said, you know, you have two options for plant oil use in diesel engines, and I use the word plant oil mostly because what's a vegetable and what's a plant? You know, is canola, is it a vegetable? I don't know, you know, you tell me. Or other plants that are, you know, whatever, is palm a vegetable? I don't know, you know. I'm not using palm oil, you know, but most of the oil that's used here is canola oil anyway. And so biodiesel chemically, altered plant oil and so on, and then the vehicle conversions. And as I said, you know, I feel really a bit smug about it when there was a discussion of the biodiesel producers about, you know, what to do with the glycerides. You know, they have this gooey stuff left over, and what do you do with it, how to compost it, and so on. And there's sometimes toxins in it from the process, chemical process. And yeah, and I filter my oil. It's so simple, you know, this is my filter bag. It's not my cooking hat or something like that. It's my filter bag. I make a hole in a barrel, pour the oil in. That's going down to 10 micron, which is the micron rating of most fuel filters. And I let the oil settle, you know. I let the oil settle before I use it, and to take the top off, portion off. If you let oil settle, within 3 weeks you have about 5 micron, except for the top floaters, you know. So if you don't use the bottom part. And 5 micron is what like the TDI, the modern engines use in terms of the filtration. Most engines, the direct injection engines. So this is for my oil processing system here, you know, and yeah, and then I have my fuel. And the nice thing is, what I can always say, and I can also feel smug about it, that I say, well, you know, you can dip your finger into my fuel, lick it, and it's okay. You know, you can do that. Not that I recommend that, okay? Just because your finger has moisture and I don't want moisture in there, so. No, it's waste vegetable oil, and it's gone to waste, huh? It's bad tasting, yeah. It's called waste oil for a reason, so it's not, shouldn't be used extensively. But, you know, that's what I can do. So, the considerations in using any plant oil biofuel system is yeah, that diesel engines are optimized for fossil diesel, and that there are different properties in viscosity, and that you must organize your fuel supply. Just short excursion on some technical issues here. Dan has talked about it a little bit this morning, and if you have any specific questions about specific engines, I'm also willing to answer those in questions later. The problem in some engines with the biofuel, with the biodiesel, is that even when it's cleaned, biodiesel is a fairly aggressive solvent. So we talked about the cleaning out of the tank, the sludge in the tank, and going to the filter and so forth. So you have plugging out filters, you can have that happen. And the other part is that biodiesel also is fairly aggressive towards some rubber components, which can lead to fuel lines deteriorating, and also some internal, especially for the injection pump, gaskets leaking. That's why some of you may have heard the name Viton. That's why some places, or sometimes these hoses or these gaskets are replaced with other gaskets that have a different composition, which is called Viton. So Viton type gaskets, which don't have that susceptibility to biodiesel, to the attack of biodiesel, let's say. When you go for plant oil, like when you use the direct oil, whenever you use a waste product, the waste product has also other components in it, like depending on what has been fried in the oil, simply put. You know, you may have animal fats in it, and you may have other sources of fat in it. And as I said, also moisture is your enemy. What I do in the collection, I get the restaurant that I get it from directly pour it into, when it's cooled down, of course, back into the plastic containers, you know, these little cubes that probably most of you know, and have it poured in. I supply a funnel for them, so they pour directly in, so then I eliminate the moisture problem that way, pretty much. There are some discussions about the acidity of the oil, and that can be an issue, but I've really not found that to be a serious issue. And by using a larger volume of oil and using different types of sources of oil, that's often eliminated. There are some, you know, restaurants that use a lot of, like, that just do the typical burger joints where you can see the oil come back really dark and so on, and then You measure the acidity, and usually it's pretty high in acidity. And you know, it would be good to mix that with other fuels, with other oils. In a biodiesel process, you have the advantage that you can accommodate, though, in the chemical process, you can accommodate some of that, and you can use actually worse oils, so to speak, than what you can use when you use the straight oils. So there's a bit of a selection process. And that's also a point where we both have to work together in straight oil and biodiesel, because both are relevant, both have their place. Yeah. And one of the problems that has often happened is that there's sort of a distinction or competition between the two, and I don't like that. I don't think that's necessary. I mean, I can make jokes about biodiesel, about the chemicals, and feel smug about my oil, but I'm only part of the solution. I'm part of a whole system, you know, and I totally credit biodiesel for its place within that system, and then looking at the global again. Short note, diesel plant oil viscosity. You see the red one is the diesel, the blue one is the plant oil, and that's using straight plant oil. So you can see that range at 70, 80, 90, 100 degrees, they start coming very closely together, and that's when you have proper combustion. The problem is when you can run most diesel engines just feeding straight plant oil in the engine once it's warm. The problem is if you use a higher viscosity fluid, think about your shower head. You know, if you put a higher viscosity and water in the shower head, you have thicker droplets coming out of the shower head, and they fall further, they splash actually in an engine against the cylinder walls, contaminate the oil, and can also lead to a process sometimes which is called polymerization, which is like a coating of the sides of the cylinder, which leads to further problems. So you want to preheat that plant oil, and how I'm doing that is simple. I use this thing here. This is the glorious heat exchanger that I'm using. I'm using the off heat from the engine, like from the coolant, and therefore also make the engine more efficient because the coolant's actually doing something rather than heating up the air around me. And the coolant heats up this filter unit, which heats in turn the oil that's flowing through here. And on this filter, I can put in different microns in the filter. This happens to be a 5 micron filter. I can put 10 micron filters in there, and different varieties available. The oil then comes in here from the tank, and there's a little pocket underneath which helps to collect any residue of particles or anything that comes out of the tank, which can be drained through a valve in here. And then the freshly filtered oil comes out of here. That's the process of preheating the oil. In addition, I also use a little electric stick that I have out there that gives the oil kind of the final push to really come to that kind of temperature. But coolant temperature usually runs in the 90 degree range, 90 degree centigrade range on a typical engine. So we're coming actually very close to that point, and we just need to have a good heat exchange, and that's the thing that I'm using. And in most cars, I'll use a 2-tank system, leave the original system intact, and then install a second fuel system. The problem with that is in the installation, of course, finding space for a fuel tank and finding space for the lines and installing it properly and stuff like that. But that's the fun part. That's the fun part, quote unquote fun, yeah, sometimes, where some creativity comes in. And you want to make it so that it also lasts and operates well. The other thing is, what we've also done is to go about the argument of emissions. I've helped to do a test that's been done in the States with EPA, Environmental Protection Agency standards, by Albuquerque Alternative Energies. We took an engine, it was a Golf TDI engine, ran it on diesel and ran it on straight vegetable oil and just compared simply the emissions, right? And so you can see here that this is, for example, carbon monoxide here. And what you can see here is this, the green one is the EPA limit. The blue one is the vegetable oil, and the sort of reddish one is the diesel. So you can see that in all standards, the vegetable oil was better, which was an important point to prove that it's actually better also environmentally. It still produces CO2s, it still produces NOx's, it still produces CO2 because it's a process of combustion, but it's always better, it's slightly better than diesel. Even though the engines are optimized towards diesel. So that shows that we're on the right track.
Which one's the NOx? I can't see from here. The one.
Yeah.
I was down there I think it was Discovery Science. They did extensive testing. This is biodiesel and diesel, so I'm assuming that the engine
would be very similar.
Yeah. But they, this is in a lab and we tuned an engine. This engine, everything could be controlled on it. And they retuned so that they actually got slightly more horsepower and less NOx from biodiesel in the field. So if the manufacturers down the line, get in line, then we'll even have less NOx issues and as much horsepower or more.
Well, the horsepower is a difficult issue to determine. Horsepower is, there's so many components.
Yeah.
What biofuels usually do, they reduce some of the friction in the engine, which leads to some better running of the engine. And however, the energy density is a bit less than in diesel, so you have sort of equivalent. And if you compare, of course, between biodiesel and vegetable oil, because you're taking stuff out of the original fluid, biodiesel has less energy density than the straight vegetable oil. So you're taking actually the glycerides that you take out, also potential energy, and they're sort of taken out. So there's, in that sense, biodiesel has slightly less capability than straight vegetable, and diesel is higher in the energy density.
What's that second series? It looks like they're all very similar except for the second series.
Which one, this one?
Yeah.
The CO. And it's interesting that the standard is way high, you know?
Yeah.
So the green bar is...
This is the standard.
Oh, that's the standard.
This is the limit that EPA sets.
Oh,
and they don't set limits for CO2 here. This is the, this is the, let me see.
That's okay.
We can see.
You can see?
Yeah.
Well, that's maybe carbon monoxide suggested. There. Found it. There you go. Yeah, go ahead.
Dr. Bourne, you said that the diesel engines are now optimized for petroleum diesel as opposed to plant oil. What changes would you make in a compression ignition engine to make it more optimized for plant oil?
Well, the big thing is to get the viscosity down to the equivalent of the diesel viscosity, because it's the physical qualities are really what matters here. The big problem is the cold start phase. You know, the cold start when there's no heat available. You can either accommodate through preheating, plugging the engine into something, or you run alternate fuels. You start on the regular diesel and then switch over when you have enough heat available.
But you really just need a little tickler tank, right? You don't need a full-size tank for your preheat diesel.
That is true. What I personally do is I install a separate tank, and for me it's a question of liability. If I install that separate tank and I have some toxic fuel in there somewhere that is at a location which is not certified, so I may run into more issues. So I leave the original system intact because it's been certified and so forth, and I install, depending on size, a larger secondary tank. That's just my choice. So.
If I could kind of add something to what Björn is saying, you don't have, leaving the original tank means that you don't have to stop at the gas station to refill the original tank very often. Right. Because I run a two-tank system in my car. In cold weather, in the winter, I'll put regular pump diesel in the main tank, so I've got reliable starts. In cold weather, one tank of diesel lasts all winter.
Right.
And there's another consideration. I'll get to you in a moment. Another consideration, just again a technical one. So somewhere you need to place a valve. Okay, and diesel works on having a supply and a return line. So you have a loop, and where you place the valve, you can either have one valve or two valves. If you switch simultaneously the supply and return line, then you have kind of a loop somewhere through the injection pump that has the other fuel in it whenever you switch. Right. And you can accommodate that by installing two valves, two 3-port valves, one for the supply line, one for the return line, and time that. But the timing, again, depends on how fast you're driving and so forth. You can computerize that, which you will see in my car here. You can do it manually computerized. So there is also a case for a larger tank, because if you have a larger tank, then if you have a little bit of mixing, it doesn't matter so much. If you have a small tank, then you run into like a higher content of possibly plant oil in that small tank because of the switching over. That's another consideration. Yeah.
Yeah, I was wondering in the modifications, in addition to heating up the fuel, I was wondering if you could change the map on the electronic injection,
yes.
say to maybe do multiple injections on a power stroke, or can you do more or less fuel, or increase or decrease the compression ratio, or some of those modifications, fundamental modifications?
You cannot change compression ratio easily, but you can modify several things. You can mechanically modify the injectors and install a different spray pattern. And there's a lot of discussion about that, but the difficulty is, like, I don't have a large research budget. Actually, I have none. It would be nice to find a way to research all that. Now, I know that companies like Elspeth and others have done that, and there are some injectors that propagate. They're the ones for plant oil and stuff like that. I don't know how well they work. I have not seen the data to support that. You know, theoretically, yes, having a slightly different spray pattern might be accommodating it. The other part, which is most modern engines also have temperature sensors in there. You know, they measure the temperature of the fuel, and so accommodate and adjust engine that way. And yes, you can play with that. You can play with the mapping of that. You can put resistors in there, basically fool the system to say that it has a different temperature. There are various options that you can do. Unfortunately, most manufacturers don't give us the specific mapping for their computer programs. So there are programs, of course, that can look into that, and you can change individual parameters, but you also will have to research what actual effect it then has. And that's the problem, that because we're all small providers in a sense, we don't have that big research budget. And it's frustrating because car companies, for them it would be literally peanuts to do something like that and give something out, but they don't like to doing that. But there are some modifications that you can do, and they're based on experience. The problem is basing things on experience. You rely on anecdotal reports, and they're, you know, difficult to judge. Let me just, so a couple of things here. Plant oil fuel systems, you have to look at fuel preparation, how you prepare fuel. Straight vegetable oil, waste vegetable is SVOWO, and then you have to consider vehicle type and age. Older vehicles are in a sense more tolerant in their fuel supply because they have an indirect injection means, so when you have a spray, you know, you want to have a mixture of air and fuel that ignites, that explodes. So imagine the piston, like in diesel engines, it's like, you're talking like millimeters or fractions of millimeters that's away from the head. There's not much space to inject anything really. So what most older diesel engines have is they have like a little chamber, little bubble in the cylinder head, and it's called indirect injection, and they're spraying the fuel from the side so that it swirls around, is mixed, and then can explode. The direct injection engines, which are all the newer engines, they spray directly from the top, and they have actually like a little bowl in the piston itself, where then the swirling can happen. So older engines are not as efficient, and that's an advantage in the tolerance. New engines are more efficient, which is great in a sense, but you have to be more careful with the fuel that you're using. That's why I would go to a 5-micron filter instead of a 10-micron filter, for example, in pre-filtering the oil. And you have to make sure that the viscosity is right. There's also something to be said for recycling old vehicles, because it takes a lot of energy to produce a vehicle. There's a limit to that. You know, sometimes there's so much that needs to be done to a vehicle, so it's not worthwhile fixing it up. But every vehicle takes a lot of energy to be produced. So what I also have done is I've taken an older vehicle and thrown out the gasoline engine and also the transmission, because the ratio is different, and changed it over to diesel. That can also be done. And that's also part of recycling, but it's not for the faint-hearted because it's quite involved. And sometimes you have to ask yourself, it doesn't seem to make sense sometimes from a monetary point of view. If you have a $2,000 or $3,000 car and you put $10,000 into a car, if you want to increase the value of your car, you better to give it a $2,000 shine job. You know, you get more value out of the car. That's the nature of the beast here. But if you think environmentally, then that's not necessarily the way to go. And the one-tank system versus two-tank systems, older engines, especially the older Mercedes, the 80s Mercedeses, they're very tolerant. They can actually, in this climate, in the coastal climate, and also down south, start with a one-tank system, even in winter. You may have to mix fuels a little bit, but you can start on one tank. However, it is not good for short distances. The straight vegetable oil system is not for short distances because you need to have the heat. If you switch over too early and do that frequently, you will have carbon deposits. You even have that with diesel. So think about any combustion engine is for longer distances. By the way, short distances, the first 2 minutes are most wear on the engine. The first 2 minutes of running.
Do you have any experience with seeing online these little small systems that I think some diesel trucks and truckers use, like propane powered or that sort of thing?
Injection?
Does it preheat that one tank? Do you know anyone who's done that for small vehicles to heat the oil with separate propane or some other system?
Yeah. You can, there are various ways of heating the tank. There's a coolant heating system for the tank, and there's preheating systems. What I noticed, a couple of years, like 3 years ago or so, the crazy thing, we had never traveled across Canada in winter, so we did that with my van, you know, and we camped actually and slept on one of the truck stops or some of these truck stops along the highway in the snow. And all these trucks had their engines idling all night to keep the heat up. And oh boy, that was so frustrating to just have that experience. The millions of liters that are wasted there. They've started to have anti-idling laws, and where little heaters come in. And these heaters could also be used to, of course, preheat the fuel and keep the engine warm. That would be an ideal combination. And it's done in Europe.
It wouldn't need the engine block of some of your manufacturers. That's the problem with that kind of system, right? As opposed to running off a two-tank system where the whole engine gets hot.
Yeah, but you heat the coolant. Okay. So the coolant goes through the engine and
there's enough coolant travel to the engine that the whole engine gets hot.
Yeah, exactly. And you can also add a circulation pump in order to get the coolant around, yes.
The one I have burns diesel. It's the size, it'll fit inside of a lunchbox. It's very small. Mm-hmm. It has a circulation pump, heat exchanger, push a button, it ignites, and in about 10 minutes it'll warm up your engine, the whole engine block. And since, like yours, I also have the heater line that goes back to my second fuel tank, it'll preheat, begin the preheating operation. Yeah,
and you can put a timer on it, for example, you know, put a timer on it to not waste energy and do all sorts of things that way. And then it's much better for the engine, it saves actually engine, and also it saves the first friction and so forth, and it does lots of things. You always have to find the balance, you know. If you look at the globally, well, where does the electricity coming from, right? Or whatever you use, or the propane, where's it coming from? So, just a consideration. But for big trucks, I mean, there are so many small heaters available that run on propane or even on diesel fuel and stuff like that, that use a fraction of the amount that these huge engines use for idling, you know, and heat well. So it's totally insane in my judgment to have them running all night. And lines of them, you know, just, anyway.
They also have the reefer unit motors going on.
And that, don't get me going on that. Anyway.
Sorry.
Just quickly on some of the technical, this is a valve, this is a 6-port valve, so you switch in one go, switch the supply lines and the return lines. I also have 3-port valves where you can time that between the supply and return line, as I explained earlier. So these are the components that you have. You have a valve, you have a tank, you have a valve, actually the filter comes first. This is the same as this filter, just a different color. Onboard filtration for the veg oil. So this one basically combines the two fuel systems. You have the lines going in, and usually the filter is before then. So you have the diesel filter coming in on one side, the veg oil from the filter coming on the other side, and then it selects which one it chooses. And you switch that with an electric switch in the dash. That's this filter. Then you have a little heat stick that is on only when it's on vegetable oil. It's an electric heat that just adds a final kick and allows the earlier switching over as well. There's a tank example. It's just a simple cube tank. I can make custom tanks for different vehicles so that they are not that visible. This is just a simple system. So this is an older system here that's from a Mercedes. And usually I do a puzzle. Can you see the parts? Most of it is original parts, but you can see some of the parts, and here I'll highlight them for you so you can see them. There's the valve installed. There is the filter, you know, see it from the top here, see it on the side. And then you have, in this case, it's an older Mercedes. I installed a little switch, simple switch in this case here, and a gauge for the fuel tank, for the veggie tank. A Jetta diesel, an older Jetta diesel, and then this is a truck, you know, this is a GMC truck. You can see some of the components, they're hidden away, some of the components you don't see them, and what we often see is some additional wiring and some plumbing, but I want to install it in a way that doesn't shave anywhere and that looks like it's supposed to be there. And this is the one that's actually outside, the Jetta TDI. I'll just go quickly through that. You can see the components there, but I show that to you on site, and that's the computer unit. So the case for recycling is, why do we recycling? It has less impact. If something that's been used and reused over and over again, you know, we have less environmental impact. It consumes less energy. And my case, of course, for the straight vegetable oil, we consume less energy with the straight vegetable oil than we use with the biodiesel. And yet, straight vegetable oil is more cumbersome in other ways and has some, you know, you have to do the conversion of the car. And people are reluctant sometimes to do that, of course. Then there are the warranty issues and so forth, you know. Like, that's the same with any alternative fuel that you're using, that the car manufacturers try to blame anything that happens in the car on the alternate fuels, and I've had arguments with local car dealerships on that, and sometimes proven them wrong successfully. But it's easier for me because I have a separate fuel system. I can basically leave the original fuel system intact and just have a switchover somewhere and insert a valve there. But it has the original fuel system, so I can run everything on the original fuel system. And yet I change the car. You also support local economy. I mean, these things are basically, these units are produced here in British Columbia, for example, and also the veg therm. And it supports local people like myself that, you know, can do mechanical work and could supply work to a number of shops that do that. It makes sense, for example, for people that operate fleets like universities, schools, trucking companies, to have that because they have everything in place. And then you just have to organize the oil collection. Here in the Cowichan Valley, we have an oil collection that's centralized through the Biodiesel Co-op, which supplies biodiesel and vegetable oil. So you have even a pump available here. And there is no competition with food supply because you're using recycled stuff. It comes from the food supply. So eat your fries, folks. You know, I want to have a bumper sticker. My car loves McDonald's. That would be my ultimate. I may not go there for various health reasons, but my car loves it. So I haven't made that yet. And it saves resources. So yeah, just go through that because of time is passing here. The thing is with waste vegetable oil, the filtration, gravity is my friend. I use gravity as the free energy to filter everything and settling down. And I have pretty much very little waste in that. So that's why I'm doing it. Okay, let's go for some questions here. Okay, you go first.
Have you run biodiesel through your WDO apparatus?
In the car, I have run cars that have run both, yes.
Is it pretty seamless?
It depends on the switching over, it's seamless. In some cars there can be issues with, if you use alternate fuels, there can be issues with some of the gaskets in the injection system. There were some issues, and I'm particularly leery about the, like for example, the TDI PDs, which I'm driving there, where and some of the GM and Ford had issues with the seals of the injectors, which can lead to fuel dripping directly into the engine oil. You know, it just drips through, and then you overfill the engine oil. When the piston hits the oil when it's running, the engine is toast. So that's something to be concerned about. So it's monitoring. I also advocate totally regular oil changes. I do oil changes every 5,000 kilometers, no matter what it says. That's the cheapest maintenance that you can do.
So you got a Biodiesel? It's a PE?
Yes. Yeah, I don't know what was first. I go here. Yeah.
How do you build the heat exchanger in the fuel tank, and what materials are those made out of? And well, yeah, just
okay. Fuel tank. There's something called a hot fox, which is available for diesel engines in northern climates. It's a dual stainless pipe, an outside pipe, an inside pipe. Between those pipes is coolant, and as the oil is sucked out, it heats up, and also heats up some of the contents of the tank. In the winter, in northern areas, the tank can be solid, but the stick that you put in the hot fox heats the oil so it melts and then.
Okay, so it's stainless.
Yeah.
For regular conversion, let's say you had golf TDI or whatever, for your new one, if you were to convert over, what kind of cost?
Labor and materials included about $2,500, depending on options. You can go up to $4,000 or $5,000, no problem. But just regular standard conversion, simple one.
By the way, compared to the cost of doing it yourself in Arizona, if I had to do it all over again, I'd recommend go to somebody who already has all the bugs worked out.
Yeah.
I enjoyed the process and learned a lot, but for convenience, it's better.
You're saying the optimum temperature is 90 degrees C. I'm running at 190 F.
That's pretty similar.
Yeah, 90.
Yes, well, close.
Two-thirds, what's that?
Can I go to a harder that is?
You need a computer for that. You have to deduct mine.
The simple stuff we're going to 30, but that's 210 F. That's not accurate. We need a CF conversion.
Well, if you can adjust the heat, that's no problem. You can add more electrical heat, for example.
Well, I do have a heat stick too, but I don't use it all the time.
Yeah, and you can adjust it. Yeah, you can adjust it through sensors and stuff like that. You can adjust that. Of course, everything that you use, even electrical heat, takes a little bit of friction, takes more resistance in terms of the alternator and stuff like that. There's no free energy.
No, exactly. But so which leads me now to go, because I wanted to have some clear tubing in the fuel system. So
yeah.
I could sort of.
That's what I hope.
Vinyl's crap, and if you connect it to the heat stick, you'll melt it for sure. Is there a clear temperature rated hose?
Depending what temperature you're talking about, use polyurethane, not vinyl. Use polyurethane, it goes up to about 80 degrees or so on, and that's probably the temperature that you have before the final piece,
And is local carry probably polyurethane?
Locally, you can have it at Island Hose here. I have it in stock, so. Just a couple more questions, because then I will get you on the field trip here quickly before we go to lunch and go to the car. It was you and then Joe.
I was just wondering if you typically use like a lift pump back by the fuel tank to help the oil get to the engine, or does it depend on the vehicle, I guess?
It depends on the vehicle. Some vehicles have lift pumps. Some have very extensive pressure systems, like Ford, for example. They have like 40 psi pre-pressure for the pump. Some need a little lift pump, some not. And you can switch those. Most of them, they're electrical ones, so you can switch them alternately if they're in tank, or otherwise you use them for both fuels. That depends on the layout of the engine arm and the vehicle.
Could you reiterate your comment on polymerization, please?
Yeah. The polymerization is, it depends on different oils. For example, you use linseed oil to coat wood. It develops a coating very quickly. Never use linseed oil in the engine, I can tell you that. Because it polymerizes. Polymerizing forms like, it's almost like a plastic. It forms like a solid film. And polymerization, every oil has the potential to do that under certain conditions. That can happen also, for example, that's why it's so important in biodiesel, for example, to clean it, to wash it afterwards. There's the water issue, but there's also the chemical residue issue, which can be a catalyst for more polymerization. And in all vegetable oil, it depends on what the oil is, the different polymerizations that can happen. Polymerization, well, happens when you have a coating of the cylinder walls or coating of intake and so forth, then it becomes smoother and it seals less. Or you can have sort of a sludge developing in the system, especially in the oil supply, because it just granulates. It's just, yeah, it's polymerization. It's becomes plastic, basically. It's on the way to becoming plastic.
And it will, if it's formed, it will theoretically wear off if you're not, like if you're not creating more polymerization. Could it, you know, cylinder walls, theoretically it would wear off.
It's difficult to wear it off
it's
because
pretty tough. It's really,
once it's in there, it's in there. You then have to take the engine apart to take it out. It's like the piston rings that get stuck and stuff like that. You can have a mess in that.
yeah. That's why I asked about the materials, because I think I've seen a lot of people use copper with these kind of systems, and I think copper is an oxidizing agent.
Yeah, it
which,
reacts.
You gets that kind of green slime around it when it gets around vegetable oil.
But that's different. That's a different thing. That's not polymerization. Copper reacts with the oils. That's a different issue. And I would also say don't use copper because it reacts with the oil. Polymerization is something, it's a different process. It's like, yeah, the oil gelling basically as a chemical process.
Caramelizing.
Yeah, yeah, caramelizing would be another way.
Ethanol is a cross-linked polymer.
Yeah. All right, so thank you for attending. What I will do is I'll go outside. There's a blue Jetta wagon PD. I'll be at the Jetta in a moment. I go out there and I'm showing you the system, what it looks like installed, and you can see all the different components in place. Thank you. And here's your watch.
Sorry for jumping in. I was hoping I was actually adding something to the discussion.
No problem.